Hello everyone and welcome to IC Compiler 2 Placement and Optimization Incremental Training. This slide shows all the newly introduced features supported in release K 2015.06 and onwards. So please take a moment to go through all of them. So it has all the features for each module starting from placement optimization till the post route optimization. Let's move on to the first feature, that is automatic cell density control. This feature is available from version 2016.03 SP5 and it is on by default. Overview. As most of us must be aware that IC compiler has a manual max cell density setting for better timing, which is done by cells clumping. However, sometimes these cell clumping may impact routability. Hence, this new auto density control feature allows the user to have a better density control without affecting routability. This feature is supported in all common RM flow, so there is no need to manually set cell density settings and you may get out-of-box behavior. But please note that it may still have slightly better results with manual cell density setting rather than auto density control. But it will be able to eliminate the iterations of manual cell density settings trials. Usage. Sometimes manual density creates extra routing overflow. Hence, it requires much more effort for congestion reduction and it may impact the runtime. And also, sometimes high manual density settings may also cause not routable placement results, which may lead to some iterations to get suitable density setting. However, with this new feature, that is auto cell density control, it uses the low cell density at the start of the flow and then it increases the cell density in the areas where routing density allows it. And hence it reduces the extra congestion reduction and also ultimately helps in runtime. User interface. Here is a new app option to control the auto density control feature. The default setting is on by default and is set to true. This app option is supported by all the commands which invoke course placement, such as placeopt, refineopt, clockopt, create placement, and refine placement. Please note, you can also use manual cell density setting with auto density control. Please note, you can also use manual cell density setting with this auto density control. In this case, auto density control does not set higher value of the user set cell density. Also, please note that for this auto density control feature, the tool always use zroute for global route. Let's move on to the next feature, that is pre-clustering placement. This new feature is available from release 2016.03-SP5 and it is on by default. Overview. This feature mainly allows to have repeatable placement results with minor changes. For example, minor changes of netlist or floor plan and also some software version change. It can also generate better module placement and it works even with the flattened netlist design as well. Usage. Here the slide shows the images of pre-clustering placement. Left is without pre-clustering placement while the right hand side shows with pre-clustering placement. Consider the left hand side, that is without pre-clustering placement. Here, when the netlist or floor plan or software version has changed, it generates slightly different module placement. So if you compare the two figures shown, you will see that there is not much of the changes. The changes are quite minor. However, if you consider this new features, that is with pre-clustering placement shown on the right hand side, you will note that it has better repeatability and better module placement results. User interface. To support this feature, we have introduced the new app option, that is place.course.precluster, and it is on by default. Pre-clustering placement works only first initial course placement, so please note that it does not support SPG flow. The next feature is embedded congestion-driven restructuring. This is the new feature which is available from release 2016.03-SP5, and it become on by default in version 2016.03-SP5-1 and release 2016.12. Overview. To support this feature, new option congestion_driven restructuring has been added to the pre-existing command create placement. This feature is also referred as CDR. This embedded CDR feature is on by default in release 2016.03 SP5-1 and also in M2016.12. User interface. To control the CDR in create placement and placeout command, the following app option has been introduced. First, place.course.conch_restruct. When this app option is on, then create placement and placeopt will execute CDR. Again, it is on by default in release 2016.03 SP5-1 and release M2016.12. The other app option is place.course.conch_restruct_strategy. This app option basically controls the variation of restructurings. There are three values that can be set for this app option, that is original or embed or rebuild. If the user set the value of place.course.conch_restruct_strategy app option as original, then the tool will perform net restructuring for congestion reduction. If the user set the value for this app option as embed, it will perform the same type of restructuring as original but less iteration for fast runtime. If the value specified is rebuild, then the net restructuring and also remapping of the logic cells will be performed. The default value of this app option is embed in version 2016.12 and in version 2016.03 SP5-1. Usage. Embedded CDR runs only the initial course placement. So when the user use -timing_driven or -congestion or -incremental option, embedded CDR does not run. Please note, when you use -congestion-driven restructuring option in create placement, the tool will use original or rebuild CDR only and not run embedded CDR even if you set the CDR strategy as embed. Also, please note that the CDR runs only in initial course placement and so it does not support placeopt SPG flow. The next feature is final clock routing integrated into the clock opt command. Overview. The clock opt command consists of the build clock, route clock, and final opto stages. The user specified these stages with the options -to and -from. Till the previous releases, after the user runs the clockup command, the user need to run route group -all clock nets to fix any open or unrouted clock nets. Starting from release M 2016.12, the tool fixes any open or unrouted clock nets during the final opto stage of the clockup command. So now with this new feature, the user no need to run the route group -all clock nets command after clockup command. This command is integrated inside the clockup command and hence provides an easy control to achieve a deterministic QOR. Usage and user interface. From release M 2016.12, user need to modify the flow script to avoid redundancy. So the flow before this release includes route group -all clock nets as a separate stages as shown in the left hand side column. While from this release with this new feature, there is no need of the command route group -all clock nets. Please note that if you need to run refine opt command after the clockup command, a separate clock routing command is still needed. IC Compiler 2 release M 2016.12 RM scripts have been updated accordingly. The next feature for this release is leakage optimization enhancement for routup command. Overview. The leakage power consumption is reduced by further optimizing the leakage at the delay and DRC optimization stages. Though there is a little runtime hit due to the power optimization being done at other stages, there will not be any degradation in other QOR measures. This feature also addresses ease of use as will be discussed in the next slide. Usage and user interface. With this new feature, now the leakage optimization is enabled by default as soon as the enable_power appware option is turned on. In addition, user is not required to specify any threshold voltage groups anymore. The tool identifies them automatically to achieve the best leakage QOR. However, the VT groups have to be specified only for reporting purposes as shown in the slide. The next feature is size only mode for the routup command. Overview. So far, there was no size only optimization in routup. The size only project in routup addresses the last stage ECO optimization. So late in the flow, there is not much routup can do, and so limits legalization and ECO permutations to the minimum. The size only feature, if it is on, applies to all the stages of routup. It does the optimization without removing or inserting any buffers or repeaters. Only the cell size changes. User interface. To support this feature, the new option size_only_mode has been added for this release. This app option is off by default and controls how the size only optimization functions. If this variable is set to equal, then cells with better drive strength but with same size are used. When it is set to equal or smaller, then the area in addition to other QOR metrics can improve. When it is set to footprint, only cells with the same footprint are used for swapping. The null is used to disable the size only feature, and it is like turning off the size only feature. With this, we come to an end to our presentation today. Thank you.